All right, guys, video number 2. We having fun yet? I'm having fun. I always have fun. All right, so we're going to do molecular compounds this time. So remember that these are going to be composed of two things above and to the right of that stair step on the periodic table. Now, if you're wondering what do we do with the things on the stair step, they're kind of iffy and they can be part of either kind. You should probably just default to putting them in a molecular compound, especially if they sit on the top. So if you have like a silicon or a boron, those will be on the top of that stair step. We're going to name those with molecular compound roles, or these roles that we're about to see. Okay. So again, two non-metal elements. We are only going to name non-metal containing compounds that have two types of atoms. So we're going to call these binary. Now I said two types. I did not say two. So we can have more than one of one or both of the types, but we're only going to have two types of non-metal elements in these binary molecular compounds. We also are going to have two word names. So there's going to be one name that tells us everything we need to know about the first element, and then a second word that's going to tell us everything that we need to know about that second element. Things we need to know are what the element is, obviously, and how many of it there are. We can also tell which one's going to come first or second in the formula, because we're going to change the end of the second name, and we'll have a little bit of practice of this in a minute. So we're always going to use the name of the first compound as is. Okay, so when this says the name of the first element, that's really just as is. So if we have nitrogen first, it's going to be nitrogen. And then we will see a series of prefixes in a minute that are going to tell us how many of those nitrogens that we have. The second word still is going to involve the name of the element. So we have the name of the element, but now we have to amend it because we're going to give it the ending IDE. And again, there's practice. Just hold on a minute, okay? If chlorine shows up second, then we have to change it to chloride. We still have to tell how many there are. There are some exceptions here with the how many there are, such as we can drop mono if it's part of the first element. We can't drop any prefixes with the second one. Drop nothing. Okay? We're always going to use a prefix, always here. Okay. All right, so here are those IDE endings that I had mentioned, right? So we have the name of the first element is always just the name. But the name of the second element has to have its ending changed in IDE. And we'll learn more about electronegativity later. But generally, we arrange our binary molecular compounds in order of increasing electronegativity. So the thing that has the "ide" ending tells the chemist which one is last. So we have to include it. Now, if you look, most of these are a single syllable and then the IDE ending. So there's carbide. This is not one. But here we have nitride, phosphide, oxide, sulfide. You have a few that aren't going to follow that trend, such as silicide, selenide, telluride. But for the most part, we're going to have a syllable and an IDE. Now, this is not another bad place for flashcards. I would probably put that there. If you're worried you aren't going to be able to just figure it out, make some quick flashcards, even if you just put the flashcards of these separately, and you have one card that says one syllable with IDE, and that'll help you remember the rest of them. All right, first you have to be kind of familiar with the names of the non-metal elements. There's none of these that are too terribly tricky. Most of the ones that don't match name and symbol together very well are going to be on the metal side. So it's going to be easier to figure these out. But go through the top right periodic table and make sure that you know their names and make sure that you can spell them, okay? It is not flowering. It's fluorine. If you type it wrong, it is wrong. You have to spell it right. There's other tricky ones to spell over there as well. So make sure that you worry about the spelling and that you have some kind of idea of what the symbol and the name should be when they go together. Now here are the prefixes that you need to know. So if, whoops, that's silly. If you have one thing of the one of the second element, you'll use the prefix mono. If you have two of either element, you'll use the prefix di. So if you have two nitrogens at the beginning, you will have dinitrogen. Okay. You'll have tri, tetra, penta, hexa, hepta, octa, nona, and deca. Okay. Not septa. Note that one. Students get that one wrong every now and then. Okay. Again, make yourself some flashcards. Okay. Really easy to get these right. Also really easy to get these wrong. So you got to spend a little bit of time on them. Again, just as a note, we got that IDE that we have to put in that second element of our compound. So if we look at our examples here, we have one carbon and one oxygen. If you look at the name, it's carbon monoxide, not monocarbon monoxide, carbon monoxide. Make yourself a note that you can drop mono. We made it on the other slide, but do it again. You can drop mono for the first element. Can't do it for the second element, clearly, because it's monoxide. Make yourself another note that two vowels close together sounds silly. And what do I mean by that? Well, I gotta finish writing it before I can explain it. All right, so two vowels together sound silly. We don't put monoxide because it sounds silly. We also don't usually say tetraoxide. We say tetroxide. That one can go either way. But you don't necessarily have the vowel, especially not the O vowels, in front of an oxide. Oxygen's relatively electronegative, so it's going to be important to remember that one. Here we have hydrogen chloride again. This is a common name, and it doesn't follow the mono rule. If this was on an exam and it was free response and you put hydrogen monochloride, I'd let it go. I'm not interested that you know all the itty bitty little exceptions to it. These two things are not really itty bitty little exceptions. This is kind of an exception. Okay, it's a common name. We've called it that over the years. All right, so we have N2O5 here. Your first step was to recognize what elements you have. Clearly you have nitrogen and you have oxygen. Right. Now your periodic table that you'll have on the exam doesn't have the names, so you'll have to know that the N is nitrogen and that the O is oxygen. Your second step was to know how many of them you have. Well, there's 2 nitrogens. 2 gets the prefix di. There's 5 oxygens. 5 gets the prefix penta. Whoops. And then your third thing was to remember that this first element just gets its name, but this second element, oxygen, we have to change to "ide" at the end. So oxygen has to become oxide. When we name it, we have dinitrogen pentoxide, because we have the vowel thing that we saw on the last slide. Now, it doesn't really get a whole lot harder than that. We're going to have 2 things. There's going to be some amount of 2 things. The first atom is always just going to be its name. Second atom is going to be the name, but it's going to say "ide." That's my kiddo in the background. And then you'll have a named molecular compound. All right, I'll do these really quick. CO2's carbon monoxide. Again, we don't care about that mono prefix. We don't care about that mono prefix in front of the carbon. And there happens to be 2 oxygens. You got to change the oxygen to "ide." N2O, two things in the front, so two nitrogens, dinitrogen. There's one oxygen. It comes second though, so you have to use the mono prefix. But mono oxide sounds silly, so we drop that second O and we call it monoxide. All right, here's a debate. What is the name for H2O? It's dihydrogen monoxide. What is the common name for H2O? The correct answer is water. What is the actual systematic name would be dihydrogen monoxide. Be careful how the question is asked, because we have a lot of things that have a common name, and we'll see a list of those in a little bit. If it doesn't specifically say, just assume you have to give me a systematic name. Think back to the hydrogen chloride example that we saw. If you give me a systematic name, then that will be fine. That's one of the answers. Okay, I promise. If, like hydrogen chloride, there's both hydrogen chloride and hydrogen monochloride, then kudos that you remembered it was a common name, and I will count both of those right. It probably just means I'll try to avoid that one. Speaking of historically named compounds, there are things that we just know by other things, like H2O is water. Technically, H2O liquid is water, and then we have ice and we have steam as well. Those all describe H2O. Those will be common names for that compound. NH3 is often referred to as ammonia as opposed to nitrogen trihydride. I don't think I've ever referred to it other than lecturing. N2H4 is a common reagent that we use. We call it hydrazine. Dr. Gray loves him some phosphorus, so he's probably worked with phosphines. He makes catalysts using that. And then we have nitric oxide and nitrous oxide. This is the car thing, right? Vroom. All right. These, you know them, you don't know them, it'll be okay. Again, if you systematically name something on my exam, I'm not going to count it wrong. So just go with systematic names. This one you'll see a lot in lab. But it's of that list, it's the most important of them. All right, so I'm going to go ahead and do this, because we're going to have pictures probably on the exam. So this looks like there's 2 blue balls and 1 red ball per compound. If the blue ball is nitrogen, then there's going to be 2 nitrogens, and there's 1 oxygen. The oxygen's the more electronegative, and it should come second. So we're going to say dinitrogen monoxide. Now, I'm probably at this point in the course not going to ask you which one's going to come first and second. I will give you answers that make sense, okay? Notice that there's not oxygen dinitride as an answer. I'm not going to be crappy like that. We haven't talked about electronegativity. We're not going to talk about it for a little bit. What I want you to know right now is that there's 2 nitrogens and 1 oxygen. Otherwise, I will put things in the right order. All right, here are some other ones. Your copy and the notes don't have the answers, hopefully. And so there is the answers for these. PCl3, 1 phosphorus. You don't need the mono in front of it. 3 chlorides, so trichloride. Dinitrogen tetroxide. Right? We put these 2 together. It's a little clunky, so we drop that A. Dichlorine heptoxide. Again, we dropped the A here because the 2 vowels together sounds a little clunky. All right, that's essentially molecular nomenclature. So your job is to memorize the prefixes and be familiar with the nonmetal compounds and the whole procedure for naming by the time I see you Tuesday or Wednesday, depending on what section you're in.